Hello everybody. The point of this video is to walk you through the steps to build your very own oscilloscope on the cheap using an Arduino. I'm going to call this project the ArduinoScope, and this will allow you to do basic oscilloscope type functionality using a very inexpensive Arduino board that will get you started on electronics projects without needing to spend the hundreds, if not thousands or tens of thousands of dollars for a proper lab grade oscilloscope. Okay, so how are we going to go about doing this? So the Arduino has an analog input channel or many analog input channels. And so we're going to utilize one of those channels to be one channel of our oscilloscope. Now, on top of that, we're going to utilize one of the digital input channels to read the signal from a button that will allow us to use a trigger functionality of an oscilloscope. And so this will allow us to not only see the signal passing by, but we'll also be able to basically pause the signal and analyze it if we need to, or take a screen capture of it if we need to. And so this trigger functionality is a very useful functionality within an oscilloscope. So we'll walk you through the steps of building the external circuit to do this, as well as writing the small amount of code that it'll take to build your very own one-channel Arduino scope. Okay, let's get started. So the first thing we're going to need is an Arduino Mega, like the one we have pictured here, but you could use any Arduino, it doesn't matter. And we're going to use basically two components and some wires to connect this thing as our oscilloscope. Okay, so the first thing we're going to want to do is place a button, and we'll place it all the way at one end of our breadboard like this. And this button will now act as our trigger button, okay? And so when we want to pause a signal or trigger a signal, we can press this button to trigger the signal. Okay, and the top of this button, we're going to wire to our 5-volt rail or a hot rail. Okay, so I'm going to wire it like this, and I'm going to make this wire red to indicate that this is a power wire. And then the other component we're going to utilize here is a 10 ohm resistor, or I'm sorry, 10 kilo ohm resistor. And I think that that is currently 10 kilo ohm. Okay. Okay, so the 10 kilo ohm now will go between the bottom section of the button, and we're going to wire this now to the ground rail of our circuit. And we're going to want to make this wire a black wire so it indicates that this is the ground side. Okay. So that's the only thing we're connecting now. So we've connected the hot rail to the top of our button, the 10 kilo ohm resistor to the bottom of our button, and then connected that other lead of the 10 kilo ohm resistor to our ground rail. Okay, so then the final thing we need to do is connect our rails to our power and ground on the Arduino. And so we'll connect the 5-volt to the hot rail as so. And then we'll connect we'll color that red. And we'll connect the ground to the ground rail, color that black. Okay, so now 5-volt and ground will be brought over to our board through the rails. And then the final step here is we're going to want to connect pin 2 of the digital I/O lines to the other side of the bottom of our switch. So I'm going to wiggle this wire just a little bit to get it disconnected. And we'll color this wire blue just to indicate that it's connected to one of the digital I/O lines. So now that we've connected our trigger button to our digital I/O line, our next step and final step is to just bring out the probe that we're going to use as the oscilloscope probe and connect that to our analog input A0. And so I'm just going to wire a random spot onto the breadboard here. And I'm going to color this wire green just to indicate that it's a probe from the breadboard. So I've just placed it at this random spot here on the breadboard. But what you should do when you want to make a measurement is actually place this wire wherever it is that you want to make the measurement. Okay, so you can just move this wire now to whatever point you want in the breadboard, and that'll be as if you're touching the probe of your oscilloscope to that particular point. And I'll shoot another video after this with an actual Arduino, with an actual breadboard, and we'll walk through what this will look like with an actual system.